All right, coming attractions this week. First of all, let me remind you, on Thursday will be test number 3. We'll start promptly at the top of the hour. On test days, I try and get here early, so if you have any last minute questions, I'll be around. Hopefully you don't. Also tomorrow, I will be doing my world famous review for the next test. I don't know if it's world famous, but how many people want me to do a review? Back by popular demand, Tuesday will be my review. All right. Now, I have a surprise for you. Since it's spring, the weather's nice. I was speaking about spring and weather nice before your surprise. Let me remind you, for the lab, no open-toed shoes, no flip-flops, no shorts. Also, if you're wearing leggings, make sure they come near your ankle. And also, no open midriff. And the other thing, first of all, for this week's lab, since I'm writing my own to-do list that I'll hand out, you don't have to do a to-do list. There'll be a fun lab because you're going to make not one but 2 polymers. Now, for the surprise. If you go to course information, you'll know there's lectures, recommended problem set answers, and oh look, what's this extra credit project? Let's find out. Two days later, boy, is system slow today. Boy, if I knew how to knit, I could do this scarf. While we're waiting for this, did anybody happen to pick up a bottle of vinegar and think of acetic acid, which is a carboxylic acid? You pick up a bottle of mouthwash and see if it has a quaternary ammonium salt that is in the product, or do you look at a fabric softener and think about quaternary ammonium salts? Extra credit project, 10, yes, 10 bonus points. What do you have to do to get your 10 bonus points? Well, let me make it a little larger so nobody gets a headache splitting. And what you have to do is create a printed, not handwritten, printed chart that contains 10 organic molecules which are found in the ingredients list of commercially available products. You can use one molecule only once in the chart. Like if it was ethanol, you can't use it in 3 different products. And you can get up to 3 molecules per product. In other words, I want you to look at more than one product. And to get full credit for that molecule, 1 point, all entries in the row of a chart must be correct. For each entry, record the name of the product, the name of the molecule that's you're picking in that product, or the either common or IUPAC. In this case, the example would be ethanol, and then you have to name one of the functional groups. If there's more than one functional group in the molecule, you only have to name one. If there's only one functional group, that's the one you name. Be sure to put your name on a chart. For some reason, a lot of times students forget to do that. And I can't tell who handed it in because of that. Now, let's look at the example. I think you're all familiar with. If not, I will be more than happy to show you how to do a chart in Microsoft Word. I think that's the word processor most of you use. And example would be product, brand X wine, and then it would have ethanol, which is an organic molecule, and the functional group in ethanol is an alcohol. If you had this down, you get 1 point. You need 9 more, and that gets 10 points. That's like getting 10 more points on any test or anything. This goes to your total. Now, to make this a little interesting, you cannot use the following molecules: sucrose, otherwise known as sugar, ethanol, isopropyl alcohol, acetone, ethyl acetate, or propane. Every other molecule is available to you. You can't use the following products: beer, wine, vegetable oil, vinegar, gasoline, propane gas, natural gas, orange juice, milk, sugar, or butter. Anything else you can purchase is fair game. You can use it. Now, ingredients must appear on an ingredients list label on the list. You can't say banana and say isopentyl acetate, because I'll tell you, I've never seen a banana with the ingredients on the label on the banana. Same thing with other things. It's got to be on an actual list. And it must be a functional group that we discussed in class. There are other functional groups that are available, but we haven't discussed them. Usually when students put those down, they always get it wrong. So let's limit it to those that we did in class. Now, this is due by the end of class, May 4th. That's test number 4. So by the end of that class, or when I walk out the building that day, I must have that. No late projects accepted. Now, please note this is totally optional. You don't have to do it. But if you do and you get it right, it's like getting 10 more points, 10 big ones. And let me talk about a few things. Beware, not all labels, names on labels are UPAC or common, and they don't follow the UPAC convention. Students always see simethicone and say, oh, in the end is ketone. No, this is a common name for a silicone compound. And it's not a functional group we talked about in this class. We couldn't use it. Now, how do you figure out what functional groups are in the molecule? Well, you've learned how to play that fun game, circle them in the functional group, and you know how to find the structure. How? Go to Google and put in the name of whatever you're looking for. And if you don't see it, usually if you add after the name chemical structure, the first 4 or 5 websites on Google search will have a website that has the structure. Now, the other thing you can do is if you think you have the structure, you can come in and ask me. Because the public service I'll be doing for the 10-point extra credit project is, before it's due, show it to me, and I'll tell you if anything's wrong. And I'll say, look, you better change this or this or get a new molecule. Common things people put down: ammonia, that's inorganic. Sodium chloride, no, that's inorganic. This is organic chemistry. And therefore, if you make any effort to do this and show it to me before you hand it in, there's no reason why each and every one of you shouldn't be able to get 10 points. Any questions? And this is on Blackboard. If you look at the course information, you can see it right there, and you can pull it up anytime or print it. All right. Now, if I remember correctly, I promised to do today the Amides and Amines problem set, so I promised. Oh, by the way, just to show you how easy the extra credit project is, I'll never be a hand model, but anyways, if you go to any store, this is an older one, you can get Carmex, and if you look on the label, there are a number of things. Oh look, phenol, and you can put down Carmex phenol alcohol, or Carmex phenol and aromatic compound, and either one of those would be correct, so you could all use Carmex phenol alcohol. That's 1 point. So, see? And there are 2 others you can get from here easily. salicylic acid, lanolin, camphor, menthol. Those are all. So I can get 3 out of this, and I only need get one of these, or take a picture when you're at a store with your cell phone. You don't have to show me it, and there you go. See how easy it is? Kids, if you either go into your bathroom, or if you don't want to do that, you go into the local big box store and go into personal care items where they have the shampoos, hand creams, and all that. Within about 2 minutes, you can get all the molecules and products you need. You just have to look up the structure. I should tell you this, that any store I've ever been at, and I do this all the time, if you pick up something and look at the label but don't buy it, they don't care. All right, let's go through the problem set. Remember, test number 3 is coming up on Thursday. How do you study for test number 3? Like my other test, do the problem set. Just study your notes. All right, first one, give the IUPAC, and now I'm doing something different. What are the common names? This was Amides. I've only asked you to learn the common name. And let's look at the following. As always, look for what's different, what's not carbon, what's not hydrogen. We'll show you nitrogen. Let's do B. What do we have on there? This is an alpha group, alkyl group. It's an amine. And common names, name each alpha group as our group is an alpha group, and add the word amine. And that's ethyl isopropyl, or you could have put isopropyl ethyl. Common names, there's no alphabetical order. C, the common name is the IUPAC name, amylin. Since over the week, oh, by the way, once in a while I get carried away, and especially areas I've worked in. Cross off D, it's ethanol amine, but I'll never put that on the test. And since I have, oh, a question, yes, right.
On A, why wouldn't it be N-butyl?
On A,
Yes.
as always, the hardest thing for me to hear. I forgot the N there. That should be N-butyl. Is that the one?
Okay, yes.
Add Dr. White.
Thank you.
Thank you. Well, let's keep an eye out for any other mistakes I made. All right, let's go through E. Question is, what's the common or IUPAC? What's different? Nitrogen. Ooh, it's got a plus charge and an anion, chloride anion, Cl minus. It's got 4 groups on that nitrogen, and it's a quaternary ammonium salt. 2 of them are ethyl, 2 are methyl. How do we say 2 in organic chemistry? Di. So it's diethyl dimethyl, or you can switch them, dimethyl diethyl, ammonium chloride. Here we have an amine salt, and notice amine salts are named the same way as quaternary ammonium salts. Name all the alkyl groups on nitrogen, and then add the words ammonium halide and propyl ammonium chloride. Oh, once again, I got over-enthusiastic. Cross off C, I'll never do something like that on my test. All right, A, B, C, or D. Anybody have a question? Yes?
D.
D? All right, let's take a look at this. Question is, draw the structure of the following. And this is one of the areas I worked in heavily, so it's near and dear to my heart. And you start to write. Chloride, ooh, Cl minus. Ammonium, this could be a quaternary ammonium salt or an amine salt. How do you tell that? How many alkyl groups? Now, dimethyl, 2 methyl groups. And it doesn't matter which side you put the methyls. There's another way I could draw it that would be acceptable, and I'll do that in a second. Now, this is a group I talked about in class, tallow. When we get further into fats and oils, you'll learn more about what is tallow group. But for now, we'll just abbreviate it R sub T. And therefore, it's ditallow, R sub T is the tallow group, dimethyl ammonium chloride. You put the chlorine over here, chloride over here. You don't have to show charges, I do. And you could have also drawn it this way. It doesn't matter which sides have the RT, which sides have the methyl groups. You can take any side as long as each side only has one. Yes?
I have two questions. Do you have to have the charges?
No. Next question.
And then B, why do you have to put the H for after the N?
Why is what?
Why do you have to have the hydrogen under the N for B?
Oh, it could be above it, because nitrogen always has 3 bonds to it unless it's in a quaternary ammonium salt or an amine salt. And therefore, give me a second, that's why. Let's take a look and see if I did it right. B is tert-butyl ethyl amine. So the nitrogen, the word amine tells you there's a nitrogen. And then it's got a T-butyl group, my favorite, and an ethyl group. Well, how many bonds to nitrogen without the hydrogen? 2. And amines, nitrogen always has 3. So we have to use a high-level math. 3 minus 2 is 1. Now, you can put that below or above, or you can put, all it matters is one side has a hydrogen, one side has an ethyl, one side has T-butyl. Doesn't matter which. That's just the way I drew it.
I think you already answered my question,
What?
but so I can put the H next to the N, it doesn't have to go above or below.
That will work also. I usually don't do that because students get confused.
Okay,
But that would be acceptable, and you have all these people around you as witness, I said that.
thank you.
If you haven't realized by now, when I grade a test, I don't sit down and say, oh, how many points can I take away? Oh, is this right or not? If it is, good. If it's not, can I give any points? And this is my philosophy of grading. I also got carried away. This cross off E, that will never be on the test. We'll learn more about amino acids, and I won't ask you to learn how to name them. And while we're in the neighborhood, I have methyl tert-butylamine, and you can draw it this way. I didn't draw it. Oh, here. Answer your question. I also did it this way here. I should have done it the other way too, but in writing, you have definite proof. I said the truth. Wow, that sounds impressive. All right, look out, it's really awful humor Monday. All right, next one. Draw the condensed structures for an organic product or products. On test number 3, like test number 2, they'll be 60 points, and 3 or 4 of them, I can't remember which, will be synthesis, but the bulk will be like this. Let's look at ABC or ABC. Anybody have a question on A, B, or C? And the answer is no, so I'm going to do one. What is this? This is nucleophilic attack on a carbon with a halogen. The non-bonding pair of electrons attack. If we look at B, primary amine alkyl halide attacks with base, you remove the HCl that's formed, it's neutralized, you get a secondary amine. In this case, R is methyl, R prime is isopropyl. The carbon with the halogen is the carbon the nitrogen will be bonded to. If you put this on the N carbon, I'll mark that wrong because that just doesn't happen. Oh, that's a juicy, because this reaction helped pay my mortgage, a couple of new cars, and a whole lot of other things got me to Europe, Mexico, Canada. Helped pay for a lot of nice stuff. But anyways, let's take a look at what do we have. R sub T is tallow, an alkyl group. Methyl ditaloamine, RX, alkyl halide base, tertiary amine, alkyl halide, nucleophilic attack to make a quaternary ammonium salt. This is one way of drawing it, dimethyl ditaloammonium chloride, which help pay everything. Let's look at D, E, or F. Anybody have one? Let's look at D. What do I have that's different? Nitrogen compound. It's an amine. What am I reacting with? HCl, acid. Any acid with an amine makes the amine salt. Proton transfer, I have 2, I'll have 3. I have the chloride anion plus charge. You do not have to put charges out. Now, if you notice the next couple of, oops, I see people writing, so I'll slow down. Remember, all these answers are available to you 24 hours a day, 7 days a week, as long as the COD system is up in Blackboard, on Blackboard. And you don't need any special software. All right, let's look at F, same thing, tertiary amine, HX. You have proton transfer, and you get this amine salt. Now, cross off G, I got carried away, and under these conditions, this is a base, acid, you get amine salt, and this is diethanolamine. You look at some of your skin creams and other personal care items, you'll see things in there near the end of the list like ethanolamine, diethanolamine, and triethanolamine. And these are used to adjust the pH so it doesn't irritate your skin, which is a good thing. Think if you're putting something on your skin and your face, all of a sudden you start turning red and blotchy. Are you going to be happy? No question.
For E, shouldn't it be NH instead of NH2 because you said 3 bonds?
For E,
Yeah.
I mean, is that wrong?
Yeah.
All right, hold on. When you have an amine salt, you have 4 bonds to nitrogen. This is the tricky part. When you have an amine, primary, secondary, tertiary amine, 3 bonds. It's important enough. This is different from carbon, where you can just routinely know that. For primary, secondary, tertiary amine, 1, 2, or 3 R groups on nitrogen, you're always going to have 3 bonds to nitrogen. But a quaternary ammonium salt, where you have 4 groups on nitrogen, or a quaternary ammonium salt and an amine salt will have 4 bonds to nitrogen. And if you look at this one right here, E, how many alkyl groups do we have? 2. It's an amine salt, because that's the reaction product. Therefore, 4 minus 2, 2 hydrogens. If we go back and look at the quaternary ammonium salt on C, how many groups to nitrogen? 4. In a quaternary ammonium, 4 minus 4 is 0. Now, how can you tell that? 1, if you see a plus charge on nitrogen, you know it's either a quaternary ammonium salt or amine salt. And I always put charges on my test, and so does the ACS. 2, if you see at the end of the name, ammonium halide, ammonium chloride or anything, that tells you there's going to be 4 bonds to nitrogen, okay? And that's how you, it's confusing. It's one of the things students do have trouble with, which is why I put it on the problem set. All right, let's get back to it. By the way, thank you for your questions. As always, all questions are good questions. Because it helps you and probably helps a lot of other people too. All right, let's do H, I, or J. Anybody have a favorite? Well, in that case, I'm going to do high. Now, what's different? Ooh, a benzene ring. Do you know the reaction of benzene with hydrogen, excess and nickel catalyst? Not really. It's very, very, very hard to hydrogenate with double bonds in a benzene ring because you lose the aromatic stability. But, ooh, a nitrile, carbon, nitrogen, triple bond, 2 pi bonds. We have excess hydrogen, which tells you you have all the hydrogen in the world that will react with anything hydrogen can react with. And nickel catalyst, you break each pi bond, there are 2 of them, and each atom of the triple bond gets 2 hydrogens. You can write it that way. And you could write it that way. And really, it's like triple bonds you've seen before. You break the pi bond, and each one up here, I wrote it this way where I didn't put the hydrogens out. Here I did. By the way, Jay is my help to inoculate you against the chemistry instructors that you're going to test. What a big, scary R group. And really, all you have to do is what's different. Nitrile, the rest comes along for the ride. Triple bond, break it, each atom gets 2 hydrogens. All right, let's go to K, L, or M. Anybody have one they'd like me to do?
Okay.
I'll do it. Let's take a look. And now things are getting interesting. We have 2 organic molecules. What do I see here? Ooh, 2 oxygens, carbonyl, hydroxyl group, the same carbon, carboxylic acid. Ooh, nitrogen, R group, and amine. Now, carboxylic acid, an amine, or R and R prime, and I don't have it on there, so I'll do it on the board. R and R prime can be hydrogen. In this case, one of them is. And therefore, carboxylic acid, amine, you form an amide. I put down water because students would get upset what happened to the water, and I don't like upset students. That's not fun. But anyways, what's R? Methyl. Draw your carbonyl, nitrogen, methyl here. What's R double prime or prime methyl? The other one is a hydrogen. Remember, an amide, just like, I can add here, an amide also has 3 bonds to nitrogen. So nitrogen has 3 bonds to it unless it's an amine salt or a quaternary ammonium salt. And that's how you do it. And if we look at L, benzene ring, you know benzene ring with ammonia? In this case, R prime and R double prime are both hydrogens. No, but this is a carboxylic acid and amine, but in this case, it's really ammonia. And R prime and R double prime hydrogens are benzene ring. You get, that's called common name benzamide. And here I do it again, same thing. Same thing again. All right. Anybody have any questions on M and N? Yes.
Just before M,
Which one?
L.
L.
NH3, why did it become
What?
NH2? NH3,
No. How many bonds to nitrogen?
3.
All right. Let's take a look at this.
Oh, I see it. I got it.
Remember, the carbonyl carbon is 1 bond.
Okay, I got it now.
And that's a good question, because now you know that's part of what you count. And that's how you learn about these things. This would be 1 bond, therefore 3 minus 1, 2. And that's how you get it. So don't forget, count the carbon bonds too. All right, let's look at OP or Q. Anybody have a favorite? Oh, let's do P. And now if we look at this, the question is, what functional groups are reacting HCl, which is the acid, plus water? Why HCl? That's the acid in your stomach. And now, what do we have? Ooh, benzene ring. Does anybody know a reaction of HCl and water and benzene ring? Because I don't. No. So this is an R group carbon. This is an amide. And when you do acid hydrolysis of an amide, you get back the carboxylic acid you would have used to make that amide. And you don't get the amine, you get the amine salt, because remember, an amine is a base in the presence of acid, it forms an amine salt. So if we look at this, this is R. Now, R prime and R double prime on an amide, either one or both can be hydrogens. In this case, one is, the other, we'll call this R prime, or you can call it R double prime, is a methyl. So here I'm going to get benzoic acid, R is the benzene ring. Then here, R prime is methyl, R double prime is hydrogen, so 1, 2, 3, 3. And chloride anion, you don't have to show charges. Oh, let's do one more. These are fun. And if we do the following, Q, here I really threw in everything but the kitchen sink. And if you look at this, you can be overwhelmed. No, you shouldn't. Actually, I can move this up. What are we reacting? This is an amide. How do you know that? Carbonyl. Carbons here. Nitrogen, carbons, carbons, amide. We're reacting with HCl and water. What do you get? The carboxylic acid plus the amine salt of the amine you would have used to make that. Anyways, therefore, if we look at this, all you have to do is carbonyl, nitrogen. What's on the carbonyl? R. On the nitrogen, R prime, R double prime. One thing sometimes my software does, and I miss it because it likes to do it when it's crowding stuff, this is called less justified hydrogens. It could also be on this side, which I normally correct. I do it there, right justified. What's R? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 carbonyl, that carboxylic acid. What's my amine salt? R prime, methyl, R double prime benzene, 2 hydrogens, plus the chloride anion. And next, R, S, and T. Notice I'm getting challenged, alphabetically challenged here. Never mind. All right, any questions on any of those? Well, in that case, I'm going to do S. And if we look at this, what's different? Carbon, oxygen to it, and the same carbon, nitrogen. This is a carbonyl, this is an amide. Reacting with sodium hydroxide, base and water, base hydrolysis of an amide. What do you get? Not the carboxylic acid, because in the presence of base, this becomes the carboxylate anion, and then you also get the amine that you would have used to make that amide. So if we look at this amide, carbonyl carbon, that's where all the action is, so keep your eye on that. Benzene ring, R. Notice R and R prime can be hydrogen. This case is true for that too. and therefore, one of them, our prime is methyl, our double prime is hydrogen. Here you get this carboxylate salt, and you get this amine. All right, now, as I stated, on test number 3, I'm going to have a couple synthesis problems. Let's take a look at A, B. Anybody have a favorite? You do B? Okay. And we look at this, what's different? 4 groups on nitrogen. They're all alkyl, halogen anion. What do you have? A quaternary ammonium salt. And by the way, I wrote this wrong. I'm obviously missing something there. This is what it should be. Everything's all correct. Anyways, what do you have? A quaternary ammonium salt. You have dimethyl, diethyl. And how do you make it? Tertiary amine, alkyl halide in the presence of base. And therefore, I can say 2 of these are R and R prime, and this one is R double prime. Therefore, our triple prime is a ethyl group. The anion is chloride, so X is chlorine. My alkyl halide is that. My amine is this. Or I can switch it around and say this is R and R prime, one of these is R double prime, and I get this amine, and my R triple prime is methyl with that alkyl chloride. And either one of those would be correct. Wow, time flies when you're having fun with amines and amides. And as always, remember, these are available to you. And if we look at C, what do we have? An amine, not just an amine, a primary amine. What are we reacting with hydrogen excess and catalyst, nickel catalyst? It's going to be a triple bond. Now, listen carefully, important thing. Am I adding any carbons here? No. So if I end up with 3 carbons, I better start with 3 carbons. And that's an important thing in synthesis to remember. I guess you call that common sense, but greatest mentor I've ever had, Sid Shapiro, used to always beat my head. He'd say, Sonny, common sense is not common. And he was right. By the way, at that time I was in, Sid was about 35, 40 years older than me. He used to call me Sonny, and I'd say, no, you're not my father, and we'd laugh. All right, let's look at D and E, because I have time. Let's look at D. What's the starting material? What do we have? A carboxylic acid, amine salt. What are we reacting? Something with HCl and water. What is that? An amide. If we look at the carboxylic acid, that's my R group. I'm the carbonyl of my amide. If we look at my amine salt, this is R prime. One of the hydrogens is going to be R double prime. Therefore, if I put that together, start with the carbonyl, let's attach that R. Nitrogen, one of these is hydrogen, the other is N-propyl. And finally, let's do D. We're reacting something with sodium hydroxide and water. We get a carboxylate anion and an amine. What do you have to start with? An amide. Carbonyl carbon is R is attached to it. On the nitrogen, R prime and R double prime, one or both of those can be hydrogen. In this case, one, the other is ethyl. And here's this. You could have the hydrogen coming down also. I guess you can say I'm inconsistent, whether I bring it down or put it to the right. Either way is correct. Any questions on amines or quaternary ammonium salts, amine salts, or amides? Remember when you go home, look at a box of fabric softener and think that has, or a bottle, that has a primary ammonium salt. And when you leave the building today, you smell something nice from the flowers. Which did you think of? Esters. For those who came in late, remember tomorrow, because of the warm weather, no, I'm not done yet, hang in there. Don't forget, because of the weather, wear proper clothing still. All right. You know what I think you guys are in the mood for right now? Time to play that fun game, circle and name the functional group. And that's where you have fun, circling and naming the functional groups in the following molecules. Have fun, and remember the way you play this game. You're not being asked to give the name of the molecule, the circle and name the functional groups, and have fun. By the way, everybody keep your fingers crossed for the Hawks. Let's see, the sign sheet maker one. Let's see. give you 35.2 seconds more. Point one, point zero, 1.5, point two, time's up. Put down your pens, hands in your note. By the way, speaking of notes, somebody from Thursday's lab left their blue through. All right, I'm seeing you right now. All right, let's take a look at this. What's different? That's how you play this game. Nitrogen, carbons here, and amine. What's carbonyl, carbon double hydroxyl carbons, carboxylic acid. Carbonyl again, oxygen's here. Carbonyl, oxygen, carbon's here. The oxygen has carbons, so this is an ester. Something near and dear to my heart. And it's got nitrogen, plus charge, 4 alkyl groups, 2 plus 2. Anide, this is a quaternary ammonium salt. And notice I've been good, I haven't used slang. And over here, what's different? Ooh, carbonyl, oxygen to carbon, double bond, nitrogen, carbons here, here. Amide. And finally, F, just about everything I could think of. Carbonyl, oxygen, carbons, ester. Nitrogen, carbon, and amine. Ooh, carbonyl, nitrogen, on carbons on there. Amide. And that's how you play that fun game. Circle, name the functional group, and remember, tomorrow you don't need to do this. Wear proper clothing, because if you don't, I will not let you laugh. And enjoy the nice weather. I'll see you tomorrow.